are going to do some fun fractions, word problems, fun fractions that have to do, the ones in your journal have to do with exercises that burn calories, or not even exercises, activities that burn calories. So I need you to flip to page 256 in your math journal, please. And you should see this chart for burning 100 calories. Give me a thumbs up once you're there. And May and Maddie, put your video back on, please. Good, I see a couple girls are already there. I see flipping pages quickly. Beautiful, beautiful. Okay, so as you get there, just start reading over the chart so that you understand the information on there while we wait for everybody to get there. And now I'm going to read it to you. The table shows about how long it takes to burn 100 calories doing a variety of activities. So on the left is the activity. On the right is the time it takes in hours to burn it. So one thing you'll want to notice is that if something takes less time, I want you to write this down next to your chart too. If something takes less time to burn the calories, that means you're burning calories, we'll just write cals, faster. That's a big idea we need to remember when we look at this table, right? If something takes less time, that means you're burning the calories really fast. And the opposite is true as well. If something takes more time, you're burning, yeah, I know, McKenna, I was surprised by that one too. McKenna noticed chewing gum. It actually does burn calories. Oh, but McKenna, this is a perfect example to look at. Look, it would take, though, 11/12 of an hour. So it takes a long time to burn 100 calories chewing gum. And that means you're burning them really slowly, right? Long time equals slowly. I know, your body's fascinating. Even in your sleep, you're burning calories. Learn something new every day, right? Okay, but again, you're right, sleeping, whoa, sleeping would take an hour and a half to burn 100 calories, so that one's really slow. Okay, let's do a couple problems, Libby, and then I'm going to come to burning questions on these. So this is not a problem in your book. This is just for us to practice. So get your fingers, wiggle your fingers so they're warmed up, so you're ready to type in the comments. You're going to look at the chart in your book, but answer my questions here by typing in the comments. What is the fastest way to burn 100 calories? So you're trying to spot the fraction that is the smallest, right? It would take the least amount of time. Which one's a really small fraction that you could find on here? The fastest way. And I'm going to give you a hint. Try to look for unit fractions. Because if a fraction has a 1 in the numerator, that already means it's pretty small. So look through and type it in the comments once you think you found it. And I want the name of the activity because it says the fastest way. So I saw Allie's got it, May's got it. Go ahead and type in the comments when you think you know. Go ahead, Allie, and unmute. Tell us what you found and how you found it.
Well, I looked at all the unit fractions, and when it comes to unit fractions, the bigger the denominator, the smaller the fraction. And the biggest denominator I found out of all the unit fractions was 10. So, and so that's how I got my answer.
Good. Excellent explanation. Thank you, Allie. That was really helpful. Okay, so then if you were running the stairs and it took 1/10 of an hour to burn 100 calories, how many minutes is that? Type it in the comments. How many minutes is 1/10 of an hour? I'm seeing a lot of 10 minutes. Good, but check your work. If you said 10 minutes, check your work. Was 1/10. Cassidy, would you go ahead and unmute and tell us how you got 6 minutes?
I got 6 minutes by because I know that 10 goes into 60 6 times. So 1/10 would be 6 minutes. 1/10 of an hour would be 6 minutes.
Excellent. Good. Because we know a full hour was 60 minutes. So just a tenth was 6. Perfect. How many seconds is it? Type it in the comments. How many seconds would it take you to burn 100 calories running the stairs? You're going to have to do some multi-digit multiplication for this one. Type it in when you think you know. I also noticed last time girls were doing such a good job to type in their units as well. Good job, Cassidy. Good job, Allie. Good job, McKenna. So we know, and good questions too. We know that there are 6 minutes, right? Cassidy just helped us figure that out. And now we know that each one of those minutes has 60 seconds. So if we did 6 times 60, we'd get 360 seconds. Okay. Okay, Libby, did you have a question?
Yes. Wait, how did you get minutes?
So what we did was we knew that running the stairs took a tenth of an hour to burn 100 calories, right?
Uh-huh.
You with me so far? So if it
Yep.
took a tenth of an hour, we know an hour is 60 minutes, but a tenth of an hour is not a full hour. It's only 1/10.
So we
So
would
it's
have
going to
to
be something less than 60. So we just did 1/10 times 60 to convert it to minutes. And it ended up only being 6 minutes.
Okay.
Okay, because if you had 10 of those 6 minutes, that would get you all the way up to the full hour. Good question, Libby. I'm so glad you asked that. Okay, we're going to do a couple more. Keep your fingers ready. These are not in your book. These are a type in the comments one. And remember, less time means burning calories faster. So this one says, what is a faster way to burn calories, 100 calories? Playing catch with a football or singing? Well, let's take it step by step. If you're playing catch with a football, type in the comments, we will, Lila, so keep your book handy, and you need to reference it right now. If you're playing catch with a football, type what fraction of an hour it takes to burn the calories. Look in your table and type it in. Good, I'm seeing a lot of girls typing 7/12. What about if you are singing? Go ahead and look in your chart on page 256 for singing, and we have 5/6 of an hour there. Okay, so those were just numbers from the chart if anyone was confused. Good job, ladies. I'm seeing lots of good participation. So now, if I want to compare these, maybe I might think, I think 5/6 is bigger because it's 5 out of 6 pieces. That feels pretty big, but I want to be sure. So I need to give these fractions a, say it with me, common denominator. Type in the comments, what denominator could both of these have in common? That would be easier to get to, 6 and 12. 6 is 1 and 12 is 1. So what? Yes, they both are multiples of 12. So we're going to keep this one as 12. That's great. Oh, I'm loving you girls are showing your work even. We're going to keep this one 12. To get from 6 to 12, you times, hold up on your fingers, what number? Yes, times 2. So I do the same in the numerator, times 2, and I get 10/12. Now I can really easily compare, right, that singing took more time. So since we know less time means faster, the less time is playing football, which means playing football is going to be a faster way, which kind of makes sense too if you think about it, like you picture playing catch versus singing, and it makes sense that football would be a faster way to burn calories, but now we've proven it with our fractions. Let's do one more like this, and then I'll pause for questions. Now we want to know the slower way to burn calories, ice skating, or so let's do ice skating or shoveling snow. Let's do ice skating first. Type the fraction of an hour that it takes if you're ice skating. Good. 3, oops, I should do this in black. 3/10. And now let's do shoveling snow. What fraction of an hour would it take to burn those calories shoveling snow? 1/4. Good. So again, these kind of, if I picture them in my head, the pieces look pretty close to me. So to compare these fractions, I'm going to want to give them, say it with me, a common denominator. So, what denominator would be a multiple of 10 and also a multiple of 4? What denominator? Ooh, Alina's got it. Elizabeth's got one too. Elizabeth, yours works as well. So we're going to go, you could have said 40, right? Because that's 10 times 4 and 4 times 10. That works perfectly. But a lot of you figured out the even smaller one, which would be to make these out of 20. So let's start with 1/4. 1/4 equals how many 20ths? Type the fraction in 20ths in your comments. 1/4 would give you 5 20ths times 5 times 5. Okay, now let's do it for 3/10. 3/10 is equal to how many 20ths? Type it in your comments. Good job. Times 2 times 2, 6 20ths. Whoa, these were really close. 6 20ths versus 5 20ths. But now we're in business to see that ice skating takes a little more time, which means so more time means it is a little slower, right? More time means slower, so that would be ice skating for this one. So we're going to do one more journal problem. I will tell you that I think these problems that relate to this chart are trickier than the problems that you're going to see on the home link. So if you're a little bit nervous right now, like I'm having some trouble, like thinking more time, less time, what it's going to be, don't stress too much about that. The journal problems are a little bit trickier, but it's building up our problem solving skills, so we're ready. Any questions about these two problems? Ayla?
How did you get the common denominators?
Great question. So what you want to do is think, if I look at 4 and 10, what's a number that's a multiple of both 4 and 10? So it's easier if you have, we used to do it when you had your multiplication chart right on your desk. You could just look through all the multiples. But what I would say is I might start listing up multiples of 4, and I'm going to think about when I get to one that's also a multiple of 10. So I'll be like, okay, I know I have 4, doesn't work for 10. 8 doesn't work for 10. 16 doesn't work for 10. 20, yay, that works for 10. So then I'm like, okay, 20, but that's 4 times 5, and it's 10 times 2, so it works. And Ayla, the foolproof way, if you're ever really stuck, is you could just multiply the denominators by themselves, and that would give you a common denominator. Like Elizabeth, I think, typed it in right away. She said 40 could be, because 4 times 10 would give you 40, and 10 times 4 would give you 40. So that's the foolproof way. And I actually, you're welcome. Great question. I don't think there are common denominators on your home link specifically, but it's a skill we've practiced a little bit and a great tool for comparing fractions. So I wanted to practice that. Okay, let's do one together. I'm going to let you pick. Would you rather do a journal problem together just to get the practice, or one home link problem together? If you're feeling a little nervous about these, we should probably do the home link. If you're feeling pretty strong in these, we should do the journal. So type it in the comments. Okay, I'm getting a lot of home link. Okay, so I'm going to do this. You can take notes on your scrap paper, and this is what will be in Seesaw, okay? So we'll look at one problem on here together, and then if you get stuck when you go to do the home link, you could always go back and watch this recording. Capiche? Okay, so here we go. Your home link says, use the information in the table below to solve the number stories. During Marcy's school's 2-week challenge, each student who meets a goal wins a prize. So hold up on your fingers. How many weeks does this challenge last? Well, yes, I highlighted it. 2 weeks. That's important to remember. It's a 2-week challenge. If you do it in 2 weeks, you win a prize. Okay, so here were the fitness goals. If you did walk, you had to walk 6 miles in 2 weeks. swim 1 mile in 2 weeks, ride a bike 6 miles in 2 weeks, or run 4 miles in 2 weeks. And if you did any of those accomplishments, you'd get a prize. So let's look at what Tony did. Tony's going to run half a mile after school each day. Will he win a prize? So this is a yes or no question. We have to figure it out. But we can't just say yes or no right away. We need to do the math to know why. So I underlined the words after school. And you, of course, know after school means how many days? Hold it up on your fingers. Yeah, 5 days a week. So in 1 week, type in the comments what equation could you set up to show how far Tony will run in 1 week. I already saw someone type it. They read my mind and knew the question I was going to ask. Yeah, Maddie, good. We're going to take the half a mile he does each day and multiply it by 5 so that we know he ran, what's the answer to that? In 1 week, on 1/2 times 5. Not quite 4 is your whole number. Give me the improper fraction first. 5 over 2. And now convert it to a mixed number. 5 over 2 means not quite 3 whole miles. Good, Elizabeth, good, Lila. Yeah, 2 goes into 5 twice without going over. So that means 2.5 miles. So in 1 week, has he met the running goal of 4 miles? Thumbs up, thumbs down. In 1 week, has he met it? No, but good thing he has 2 weeks. Woo! So then to take it for 2 weeks, if 1 week was 2.5 miles, who could talk us through how you figure out how much you did in 2 weeks? Elizabeth, will you go on mute and tell us how you would figure out 2 weeks?
I know that 5 days is going to be the same in 2 weeks. So I'm going to do 2.5 times 2.
Perfect. And I'm going to write it down. I should have written down here before where I had plenty of room to show my work. 2.5
And I
times
got
2.
5 miles.
Beautiful, because 4, but 2 and 2 over 2, but ow, it hurts my eyes. 2 over 2 is, of course, a whole. Okay, thanks, Elizabeth. Can you mute, please?
Yeah.
So now we're ready to answer this question. If he ran 5 miles in 2 weeks, did he win a prize? Thumbs up, thumbs down. Yes. Silent cheer for Tony. Or actually a roller coaster run. Ready? Woo! Good job, Tony. So those will be, now on this, it's really going to be important that you RTQ every single time, okay? RTQ, because it's going to change up what it's asking, but you have all the tools you need.